Hello, this is the lecture for combinations and compositions of functions. We can perform operations on functions. We can add them, subtract them, multiply, or divide functions. If we're adding two functions in function notation, we might say f plus g of x if we're adding the function called f with the function called g. That simply means that we're going to be adding f of x, however that's defined, to g of x, however that's defined. We can subtract f minus g of x. That would be equal to the function f, however that's defined, minus g. F times g of x, multiply functions, and then we can divide functions, provided that the denominator is not equal to 0. We never want to divide by 0. So let's look at some examples of combining functions. If we have a function f, and that function is defined as 2x minus 1, that just means take some input. That'll be the value x, whatever value x takes on. Take that input, multiply it by 2, and then subtract 1 from it. And if g of x is defined as x plus 5, if we want to find f plus g of x, what we're looking for here is simply f of x plus g of x, which, as they're defined, would be f of x, of course, is 2x minus 1. And we're going to add to that g of x, which is x plus 5. Okay, we can combine our like terms here. Look, we have two x terms. 2x plus x is 3x. And then a negative 1 plus 5 is going to be plus 4. All right, so f plus g of x is 3x plus 4. We can subtract. Look what this one's saying here. This example says f minus g of 2. All right, in this first example, we were just finding the expression for the function of f plus g. I'm sorry, the addition of f plus g for any value that x could take on. Here we're looking for a specific value. We want to find f of 2 minus g of 2. All right, so in order for us to subtract f of g of 2 from f of 2, we need to find out what they are. So let's see, maybe we'll write it over here. What is f of 2? F of 2, we're going to put 2 in for the x. F of 2 is going to be 2 times 2 minus 1. Well, that's 4 minus 1, or 3. And then g of 2, put 2 in for the x, is just 2 plus 5, or 7. So f of 2 minus g of 2 is going to be 3, that's what f of 2 was, minus 7, or negative 4. Okay, this third example here is asking us to find f times g of x, or f of x times g of x. Here we want to multiply the function f with the function g, right? And we want to find the general expression for any value of x. So f of x is defined as 2x minus 1. We want to multiply that with g of x, which is defined as x plus 5. Okay, multiplying those two binomials. Let's see, 2x times x is 2x squared. 2x times 5 is 10x. Negative 1 times x is negative x, and the negative 1 times 5 is negative 5. When we combine the like terms here, we have 2x squared plus 9x minus 5. Okay, one more example here. Now we're going to do division. F over g is f divided by g of negative 1. Here we're looking for a specific value again. We want the input, or the x, to be negative 1. Right? So f divided by g of negative 1 is going to be f of negative 1 divided by g of negative 1. Well, we need to know f of negative 1 and g of negative 1 before we can divide them. So let's find those. Maybe we'll write those down here. Let's see, f of negative 1, that's going to be, put negative 1 in for the x, so 2 times negative 1 minus 1. That'd be negative 2 minus 1, or negative 3. Now let's find g of negative 1. G of negative 1. Put negative 1 in for x, so that's just going to be negative 1 plus 5, or 4. All right. So f of negative 1 divided by g of 1 is going to be negative 3 divided by 4, or negative 3/4. Okay. Combinations of functions, adding, subtracting, multiplying, or dividing. Let's just look at one more example and get the page turned here. Let's see. There's nothing real crazy about this other than f of x and g of x are both quadratics. F plus g of 4, that'll just be f of 4 plus g of 4. Well, f of 4 is going to be 4 squared plus 10 times 4 plus 16. And we're going to add to that g of 4, which is going to be 4 squared plus 5 times 4 plus 6. Okay, if we add all that up, let's see, maybe I'll let my calculator help me. Let's see. 16 plus 40 plus 6, 56 plus 16 plus 26. Looks like that answer is 114. Okay. Now look at this second example here, f divided by g of x. Okay, so we're back in this example, we're back to finding a general representation of f of x divided by g of x. F of x divided by g of x. Well, f of x is defined as x squared plus 10x plus 16. G of x is defined as x squared plus 5x plus 6. All right, is that it? That looks like that's the function we wanted. But when we're dividing these functions, we have a rational expression, and we know that rational expressions should be simplified if they can. So maybe we should factor the numerator, factor the denominator, and see if we have any common factors we can divide out. Well, let's see, that numerator will factor into x plus 2 times x plus 8. And that denominator, well, it'll factor also. That's going to factor into x plus 2 times x plus 3. All right, so we do have some common factors. We have, well, one common factor. We have an x plus 2 in the numerator as well as in the denominator. So those factors will divide out. Our final answer here then has to be x plus 8 divided by x plus 3. All right, so there's nothing too crazy about combining functions, just performing operations on functions. Let's take a look now at composing functions or function compositions. When we compose functions, what we're actually doing is we're applying one function to the output of another function, right? Or we're taking the output of one function and making it the input to another function. Maybe another way of saying that is the output of one function will become the value for x in the other function. All right, so if we want to take the result of g of x, or the output of g, and make it be the input to f, or plug it in for x in the function f, we will be finding f of g of x. Or we also have this little floating circle symbol that means f composed with g of x, right? This is two symbolic ways of saying the same thing. And what we're doing here, again, is the x is going to be a function. The input to one function is going to be the output of another function, right? So in this case, the input to f, or the x in f, is going to be the output of g of x. Okay, so let's look at some examples here. If we have f of x that's being defined as negative 3x plus 4, and g of x is defined as 2x minus 5, what would f composed with g of 1 be, or f of g of 1? Well, what's happening here is g of 1, whatever that value is going to become the input of f, right? So we're going to need to know what g of 1 is first. Let's find it. G of 1, let's put 1 in for x. G of 1 is going to be 2 times 1 minus 5. That's 2 minus 5, or negative 3. All right. So we now know that g of 1 is negative 3. So negative 3 now is going to be our x, or our input to f. We're going to go ahead and find f of negative 3. All right. F of negative 3 then is going to be negative 3 times negative 3 plus 4, or 9 plus 4, of course, that's 13. Okay, in the second example, we want to find g of f of negative 3. Well, we just found f of negative 3, right? We just found f of negative 3. F of negative 3 was 13. Okay, so there's our f of negative 3, it's 13. So it's 13 that we want to now make our input to g, or we want to let x be 13 in g, right? So g of 13 is what we're finding. My pen is running out here. Okay, g of 13 is going to be 2 times 13 minus 5, or 26 minus 5, which of course is 21. All right, in this third example, wait, what's happening here? F of 0. Well, here we're going to compose the function f into itself, right? Or we're going to find what f of 0 is. Whatever that is, it's going to become the input back into itself again, right? Sort of a recursive composition here. Well, before we can do this, we do need to know what f of 0 is. So let's see if we can find f of 0. Let's see. F of 0, let's see, here's f. Put 0 in for x. F of 0 is going to be negative 3 times 0 plus 4, or 4. All right, so 4 is the input that we want to put in back into f itself. So we're going to be finding f of 4 now. F of 4 is going to be, let's see, negative 3 times 4 plus 4. That's negative 12 plus 4, or negative 8. Okay. So when we compose functions, the inside function becomes the input to the outside function, right? Or we evaluate, just like order of operations, we evaluate the inside part first, and then we apply that value to the outside part. All right, so the last example here is f of g of x. Well, what do we do with this when we don't know the value? We just want to find a general expression for f composed with g of x, or f of g of x. We just want to find the expression for that in terms of x, right? So what does that mean? That means everywhere I have an x, or everywhere I'm expecting an input in f, I'm going to put g of x into it, right? Or I'm going to put all of g of x, this whole thing, it's going to become the input to f. Everywhere that I need an x, well, I only need one x, so we're just going to put g of x in there. So f composed with g of x would be negative 3 times, and again, instead of x, we want g of x, so 3 times 2x minus 5, and then I don't want to lose my plus 4. All right, if I simplify that, what do I have? Negative 3 times 2x, that's negative 6x. Negative 3 times negative 5 is positive 15 plus 4 more. So it's going to be negative 6x plus 19. Okay, composing functions. We can compose them with specific values, or we can compose functions and get a general expression with a variable. We usually say x. Let's look at a few more examples, composing functions, or a few more examples of composite functions. All right, here we have 3 functions. We have f of x, g of x, and h of x. Right, f of x is x squared minus 2x, g of x is x plus 5, h of x is the square root of x minus 4. Let's see if we can find f of g of x, right? F of g of x. So what are we doing here? We want g of x become the input to f. So g of x, however that's defined, here it is, it's x plus 5, however that's defined, that needs to become the input to f, or we need to plug that in everywhere we're expecting an x, right? So it needs to go here, and it also needs to go over here, x squared. All right, we'll make that substitution then. Okay, so f of x, we're going to have, instead of x squared, we're going to have f of g, we're going to have x plus 5 squared, because we're putting that x plus 5 in for the x. So x plus 5 squared, then minus 2 times g of x, or 2 times x plus 5. Right, we should simplify that. Let's see, x plus 5 squared, that's x plus 5 times x plus 5. Maybe I'll write it out. Make sure I don't make a mistake doing this in my head. Okay, then minus, I guess I could distribute this 2, right? Or negative 2, sorry. So that'd be minus 2x and then minus 10. All right, let's multiply. Let's multiply these two binomials. So we'll have an x times x, it's an x squared. Then we'll have x times 5 and another one, so two 5x's. And then we'll do 5 times 5, that's a 25. And then we'll bring down minus 2x minus 10. Let's combine our like terms now. So our final answer will be, there's only one x squared term, so it'll be x squared. Then we have plus 5x plus 5x minus 2x, that's 10x minus 2x, or plus 8x. And then we have a 25 and a negative 10. That'll be plus 15. Okay. What about g of f of x? Is that just the same thing? Oh no. Oh no, right? Here we're going the opposite way. Here we're going to compose f of x into g of x, right? Or everywhere we're seeing x, or we're expecting an input in g, the outside function, we're going to use the inside function. So here what we're going to do is we're going to substitute that x squared minus 2x in for the x. All right, so let's go ahead and do that. Instead of g of x is x plus 5, but instead of x, it's going to be x squared minus 2x. That's our f of x, right? Plus a 5. Well, I didn't really need those parentheses, so I could just drop those if I wanted to, and this would be x squared minus 2x plus 5. All right. How about h of f of x? Okay, so now we're looking at this third function. H of x over here is the square root of x minus 4. Okay, so that's my outside function. I'm going to stuff into that f of x. So f of x, the blue that I circled there, is going to go in for x in h of x. It's going to go right there, okay? So this would be then the square root of, and again, instead of x minus 4, it's going to be f of x, which is x squared minus 2x minus 4. Okay, and then we're going to compose that the opposite way as well. We're going to compose h into f. So I'm going to have colors here. We'll let h be this brownie color. All right, so the square root of x minus 4, we're going to compose that into f. So that's going to go everywhere we see an x. So right there and right there. So f of h of x is going to be not x squared, but the square root of x minus 4 squared minus 2 times the square root of x minus 4. And we should simplify that a little bit, shouldn't we? The square root of x minus 4 squared is just x minus 4. And that rest needs to stay, minus 2 square roots of x minus 4. Okay. Let's look at just one more example. The concept is always the same here. We're substituting one function in for the input to the other function, but sometimes it gets a little tricky with fractions. So why don't we do one that involves some fractions? Here f of x is 1 over x minus 3, rational expression, right? And g of x is 5 over x plus 3. Okay, so if we want to find f of g of x, right, we're going to put how all of g of x, how that's defined, in to f where there's an x, right there. All right, so this is going to look like a weird rational expression, but let's make the substitution. So my numerator is going to be 1 over, and look at this weird denominator. Instead of x down here, we're going to put 5 over x plus 3. Right? That's our new x, and then minus 3. All right, we can simplify that a little bit, right? Look at these 3's are going to add out here. So that's now just 1 over 5 over x. Oh, and then we should simplify that as well. That's like 1 over 1 divided by 5 over x, or x over 5. Right? Now let's see if we can compose them the opposite way. The opposite way. Let's put f of x into g of x, or find g of f of x. Right? So that this time we're going the other way. 1 over x plus 3, f of x is going to become the x, and g is going to go in right there, blue. Okay, let's do that. So g of f of x, so g of x is 5 over, and then instead of x, we're going to put all of f of x in there. So it's 5 over 1 over x minus 3. Yikes. But I don't want to forget about my plus 3 out here. Okay, now I need to simplify this rational expression. That's kind of weird, isn't it? 5 divided by 1 over x minus 3, that's going to simplify to 5 over x minus 3 over 1 plus the 3. Then let's distribute that 5. So we'll have 5x minus 15. It's over 1, so I don't really need that. Then plus the 3. So finally we have 5x minus 12 in its fully simplified form. All right, that ends the lecture on combinations and composition of functions.